Hello viewers, my name is Dr. Ajay, Associate Professor, Department of ECE from Institute of Aeronautical Engineering College, Hyderabad. Today we are going to discuss about the topic on problems on pattern multiplication. Problems on pattern multiplication. So this is the topic which is related to the course Antennas, Waves and Propagation. So let us start our session today. The topic is based upon the pattern multiplication in the arrays. So here the first problem is, draw the radiation pattern of two isotropic elements fed in phase spaced lambda by 2 apart by pattern multiplication. So we need to draw the radiation pattern of two isotropic elements fed in phase spaced lambda by 2 apart by pattern multiplication. So here there are two elements are there here. Let us see here. This is the pattern. And here there are two elements are there here. Let us assume this as one element, this is as two element, and these two elements are separated by some distance where it is given as d is equal to lambda by 2. It is given as d is equal to lambda by 2. Now if we want to draw the radiation pattern, we need to find out the value of E, that is the electric field radiated by each individual element, and the total field pattern is given by the summation of the field produced by each individual element. So the total field pattern, it is given by each individual pattern E field plus E2. That is the electric field produced by pattern by source 1 plus the electric field produced by source 2. So if we do the summation of these two at distance point P, we get the electric field PE. So based upon E, we are going to find out we are going to draw the radiation pattern of two isotropic elements. Now this process we are going to start with the pattern multiplication method. So what does this pattern multiplication method says is, so according to the basic principle of pattern multiplication, here the radiation pattern through pattern multiplication of an array, it is given by the pattern of an individual element multiplied with group pattern of all elements in an array. So the pattern, the product of the pattern of any individual element multiplied with the group pattern of all the elements in an array, we call it as pattern multiplication. So this pattern multiplication method, it is just we need to draw the radiation pattern just by inspection. So it's a method, pattern multiplication, it's a method used to draw the radiation pattern by means of inspection. So the meaning of inspection means, here we need to know how the radiation pattern will be when the elements spacing between the elements spacing is lambda by 2. So what will be the radiation pattern, we need to know. And if the element spacing is lambda, so what will be the radiation pattern? Or if the spacing between the elements is lambda by 4 or 2 lambda, so what will be the radiation pattern? So we need to know the radiation pattern of two elements separated by either lambda by 2 or lambda or 2 lambda or lambda by 4. So based upon this data, we can draw the radiation pattern of any number of elements in an array. So we can apply this technique either for 4 elements or 8 elements or 16 elements. So if we are familiar with the two elements of array spaced lambda by 2 apart, then it is easy for us to draw the radiation pattern of 4 elements or 8 elements or 16 elements array. Now let us see what will be the radiation pattern of the array separated by a distance of lambda by 2. So we want to draw the radiation pattern. First, according to the pattern, we need to apply the principle of pattern multiplication. So we need to apply the principle of pattern multiplication. So here, according to the principle of pattern multiplication, let us say E0 is equal to E1 sin theta. Assume E0 is equal to E1 sin theta. So here let us assume these dipoles are horizontal here. These dipoles are horizontal. So when the dipoles are horizontal, the radiation pattern will be perpendicular like this. It means towards 90 and towards 270. So when the dipoles are horizontal, we can take the function as sine theta. We can take the function as sine theta. But if the dipoles are vertical, the radiation pattern will be like this. The radiation pattern will be like this. So we can take this 0, 90, and this is 270, sorry, 180, and this is 270. So for this, the function we can take is cos theta. We can take the function as cos theta. So whenever the dipoles are horizontal, take the function sine theta. According to the radiation pattern is perpendicular to the axis of the array. Hence we are taking a sine theta here. So E0 is equal to E1 sine theta for an individual element. The function can be written as E0 is equal to E1 sine theta. So here, so we have derived expression for E already for two elements separated by two elements in an array separated by a distance of d is equal to lambda by 2. So in our theory sessions, we have discussed about two elements, two isotropic sources or two elements separated by a distance of lambda by 2. So based upon that, we can write as psi is equal to beta d cos theta plus alpha, we know already here, and E is equal to, we know that 2 E naught cos psi by 2. So this is the, according to the we have derived the expression according to our theory classes. That is 2 E naught cos psi by 2. Now here, what is E naught here? 2 into E1 sin theta cos psi by 2, where psi is equal to beta d cos theta plus alpha. Now if we normalize this function, 2E1 is equal to 1 as amplitude, then E is equal to sin theta into cos psi by 2. So E is equal to sin theta into cos psi by 2. So from this function, what we can say is, this sin theta function, it indicates the pattern of individual element. And this cos psi by 2, it indicates a group pattern of array of two sources. So here you are getting E is equal to sin theta into cos psi by 2. So here there are two functions, one is sin theta, one is cos psi by 2. So sin theta is nothing but the pattern of individual element. Cos psi by 2 is nothing but the group pattern of array of two sources. So multiplying these two, we get the radiation pattern of two isotropic elements spaced lambda by 2 apart. So now let us apply the pattern multiplication here. So according to the pattern multiplication, we got here psi E is equal to sin theta cos psi by 2. So accordingly, we can according to the function, we can write this as sin theta is equal to, for this, the radiation pattern is, suppose let us say theta is equal, the radiation pattern will be like this. Why? Because this is 0, this is 90, this is 180, and this is 270. If theta is equal to 0, then what is the value for sin theta? And theta is equal to 90, and theta is equal to 180, and theta is equal to 270. If you write for theta is equal to 0, you will get a 0. For theta is equal to 90, if theta is equal to 90, then sin 90 will be 1. So this is maximum here. And here, if the theta is equal to 270, it will be maximum here. So the radiation pattern will be like this. And this into cos psi by 2. What is cos psi by 2 here? So cos psi by 2 is also the same thing. So here psi means beta d cos theta plus alpha. Alpha is 0 here. The phase angle, as we are assuming, fit in same phase. The phase between the two elements is same. So alpha is 0. What is beta? Beta is 2 pi by lambda. What is d here? D is lambda by 2 and cos theta plus 0 here. So lambda get cancelled, 2 get cancelled, and you will get pi cos theta. You will get pi cos theta here. So what is psi by 2 here? Psi by 2 is equal to pi by 2 cos theta here. pi by 2 cos theta here. So here cos psi by 2. So what is cos psi by 2 here? If you take cos psi by 2 function, you will get cos of pi by 2 cos theta. So cos psi by 2 is equal to cos of pi by 2 cos theta. Now let us apply the value of theta as 0. If we take this theta value as 0, what you will get? Cos 0 is equal to 1. So again you will get cos 90. So cos 90 is 0. So you will get value as 0. So for theta is equal to 0, you will get 0. Similarly, you will get the value as 0 here. Similarly, for theta is equal to 90, you will get the value of 1. Why? Because cos 90 is 0 here. So 0 into pi by 2 is equal to 0 into pi by 2 is equal to 0 here. Let us do the function. So cos of pi by 2 cos 90. So cos 90 is 0 here. So cos of 0 is equal to 1. Hence, for this function, the radiation will be like this: 0, 90, 270, 180, 270. So when it is 90, it is 1. So when we are taking theta as 90, the maximum value is 1. So it will be, the radiation pattern will be maximum towards 90 and 270. Hence, for cos psi by 2 also, we are getting the same radiation pattern. That is, this is 0, this is 90, this is 180, and this is 270. Similarly for this also, 0, 90, 270. So here, we are going to multiply the sin theta with cos psi by 2. So that sin theta is nothing but the individual element, cos psi by 2 is nothing but the group pattern of the two elements. So if we multiply these two, so these two are maxima into maxima, we will get maxima square. That means that these two will be overlapping like this. So the radiation pattern will be like this. So here what we are going to do here, based upon the function of E, we are going to draw the radiation pattern. So according to the electric field produced by two elements, so based upon the data, here E is equal to sin theta into cos psi by 2. Sin theta means the radiation pattern will be like this. This multiplied by cos psi by 2, again the radiation pattern will be like this. So this is maxima, this is maxima here, this is maxima, here there is a maxima here, and here there is a maxima. So maxima into maxima is equal to maxima square. So that is equal to, you will get the radiation pattern as same thing. That is 0, this is 90, this is 180, and this is 270. So like this, we need to draw the radiation pattern of two isotopic elements fit in phase, spaced lambda by 2 apart by pattern multiplication. So we shall also apply the same thing, two isotopic elements in phase for 4 elements also. For 4 elements also. So here this is the radiation pattern we are getting here for sin theta and cos psi by 2. So we will get the radiation pattern like this. So let us apply this concept to for 4 elements also. Now let us draw the radiation pattern of 4 elements. So draw the radiation pattern of 4 isotopic elements fit in phase, spaced lambda by 2 apart. So spaced lambda by 2 apart. So combination of elements, we call it as one group pattern. So combination, when we combine elements, we call it as a one group pattern. So here there is a significance of a group pattern. So whenever there are 4 elements, whenever there are 2 elements, suppose let us say 2 elements. If we combine 2 elements, we call it as one group pattern. Suppose if there are 4 elements, we are going to combine 2 elements as one group pattern and 2 elements as one group pattern. Suppose there are 8 elements in an array, then 4 elements is treated as one group pattern. 4 elements is treated as one group pattern. So this is the, we need to remember what actually the group pattern means. So it depends upon the number of elements. So how many number of elements are going to combine? That number of elements, the radiation field produced, we call it as a group pattern. So here you can see here, there are 4 elements here. And we are going to draw the radiation pattern for these 4 elements here. So here, if we take 4 elements, 1, 2, 3 and 4. 1, 2, 3 and 4. This is lambda by 2. This is lambda by 2. This is lambda by 2. The spacing is. So now we are going to combine 1 and 2 as this. One, call it as A, one group pattern. And 3 and 4 as another group pattern. Here, this is B here. So let us combine these two. Let us join these two. Now what is the length between the A and B here? So here there is a lambda by 4 here up to here. Up to here it is lambda by 4. So lambda by 4 plus lambda by 4 you will get lambda by 2. And total is lambda by 2 and lambda by 2 you will get lambda. So accordingly we can write for the resultant pattern. What is the resultant pattern? The resultant pattern is equal to, for this A and B, written as pattern of A multiplied with group pattern of A and B. Group pattern of A and B here. So the individual pattern of A multiplied with group pattern of A and B will get the resultant pattern. Now what is the pattern of A? What is the pattern of A here? The combination of 1 and 2. Right? The pattern of A is nothing but the resultant pattern of 1 and 2 here. The pattern of A is nothing but the resultant pattern of 1 and 2 here. Now what is the resultant pattern of 1 and 2 again here? So in the previous slide, we have seen here, this is the pattern. That is the resultant pattern of 1 and 2. So if there are two elements combined with the spacing of lambda by 2, then the resultant pattern will be like this. So here we are going to write this as resultant pattern of 1 and 2 is this is. Now what is the group pattern of A and B? That means the elements are combined, two elements are combined with the distance of lambda. Two elements are combined with the distance of lambda. So when two elements are combined with the distance of lambda, so we need to draw the radiation pattern. We need to draw the radiation pattern here. See here, psi is equal to beta d cos theta plus alpha. So what is beta here? 2 pi by lambda, and d is equal to, spacing is lambda here. So what is the spacing here? Here the spacing is lambda here. Why? Because two elements A and B are separated with the lambda here. Into lambda plus alpha. Alpha is 0, the phase difference. So lambda get cancelled. You will get 2 pi. 2 pi cos theta here. 2 pi cos theta. So psi is equal to, you will get 2 pi cos theta. And here psi by 2 is equal to pi by 2 cos theta here. So psi by 2 is equal to pi by 2 cos theta here. So for this function, we need to write the function for E, that is, so E is equal to sin theta into cos psi by 2. We know that. So based upon this function, we need to draw the radiation pattern for this function. By substituting the values of theta, theta is equal to 0, theta is equal to 90, and theta is equal to 180, and theta is equal to 270 degrees. So psi by 2 is equal to pi by 2 cos theta here. So E is equal to 2 E naught. Sorry. So when theta is equal to 0, we will get, when theta is equal to 0, you will get pi by 2. When theta is equal to 90, you will get theta is equal to 0, you will get pi by 2. When theta is equal to 90, you will get cos 90 means is 0. So if you draw the radiation pattern for two elements separated by lambda, so you will get here, see here, 2 E naught cos psi by 2 here. So we know that E is equal to 2 E naught cos psi by 2 here, and E is equal to cos psi by 2 here. So what is psi here? Beta d cos theta. So the beta means 2 pi by lambda into d. D is equal to lambda into cos theta. Lambda lambda get cancelled. 2 pi cos theta. This is psi, and psi by 2 is equal to pi cos theta here. So psi is equal to psi by 2 is equal to psi by 2 is equal to pi cos theta here. So based upon this function, we can find out the expression for maxima and minima. So we need to find out the expression of maxima and minima here. So here the function is cos of pi cos theta. Let us assume here that E is equal to cos psi by 2. This is equal to cos of pi cos theta. So this function here. So when this function will be maximum, so cos of pi cos theta is equal to will be plus or minus 1 here. So the general solution for this, we need to find out the values of theta. So E is equal to cos of pi cos theta. So we need to draw a table here. Theta and E. So for 0, for 90, for 180 and for 270, you need to find out the values of E here. For E is equal to pi cos theta. So based upon the data that we got, so suppose if 0 we got here. Suppose here theta is equal to 0, 1. And here this is cos 180. So cos 90 plus 90 means cos 90 plus 90 means we get minus 190. So we get minus 1 here. Suppose theta is equal to 90 here, cos 90 0 here, cos 0 will get 1. So like this you need to find out the values, and based upon the theta and E you need to draw the radiation pattern. You need to draw the radiation pattern here. So we will get the radiation pattern as for lambda. If two elements are separated by lambda here, the radiation pattern will be like this. That is 0, this is 90, this is 180 and this is 270. That means here two elements are separated with lambda here. This is group pattern and this is multiplied with unit pattern. The individual element pattern we call it as a unit pattern. The unit pattern will be like this: 0, 90, 180 and 270. So if we multiply these two, so maxima into maxima is, here we are having nulls here, nulls 60 degrees, also 120 degrees. This is unit pattern separated with the lambda by 2 here, and this is the group pattern multiplied with separated with the lambda here. So we simplify these two. Maxima into maxima is equal to maxima square. That means we are going to indicate like this, and the nulls are in this direction. So 0, this is 90, this is 180 and this is 270. Where the nulls are? The nulls are in the direction of 60 and 120 degrees. 120 degrees. So this is how to draw the radiation pattern of 4 elements fit in phase separated by distance of lambda by 2 here. You can also indicate as the 60 as nulls as small lobes like this. So here you can see here the resultant pattern of 4 elements is obtained by multiplying the radiation pattern of individual element. The radiation pattern of individual element is nothing but the unit pattern. Similarly, you can draw the radiation pattern of 8 isotropic elements fit in phase space lambda by 2 apart as in the above. So here what we are going to do is, for 8 elements, we are going to consider 4 elements as one group pattern and 4 elements as one group pattern. You can see here, suppose if you take 1, 2, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7 and 8. So you are going to combine 4 elements as one comma. So this is lambda by 2. So all are lambda by 2 spacing. And the total distance is lambda, 2 lambda from here Now what is the resultant pattern? The resultant pattern is unit pattern of A multiplied with group pattern of A and B. So what is unit pattern of A here? The unit pattern of A is nothing but the resultant pattern of 4 elements. 1, 2, 3, 4 elements. So for these 1, 2, 3, 4 elements, we already know the radiation pattern. So based upon that radiation pattern, we need to multiply with the radiation pattern of 2 lambda. With 2 lambda. So we should know the radiation pattern of the 2 elements here. So we should know the radiation pattern of the 2 elements that is separated by 2 lambda. So for 2 lambda, the radiation pattern will be like this. And this is for 2 lambda. And here, the radiation pattern of 4 elements is for 4 elements. It is the individual pattern. So we are going to multiply these two. If we multiply these two, you will get like this. So we need to know the 4 element array. We need to know the radiation pattern of 4 element to draw the radiation pattern of 8 element. 8 elements here. So you can see here, this is the unit pattern. This is the for 4 elements here, for 4 elements. This is the for 2 lambda radiation pattern. If 2 elements are separated by 2 lambda, then the radiation pattern will be like this. If we multiply these two, maxima into maxima is equal to maxima here. And we are indicating the nulls here, 60 and 120 here, 60 and 120, and 0 and 180 here. So like this, we can draw the radiation pattern of any number of elements for even 16 elements also. If we want to draw for 16 elements, you should know for 8 elements has one group pattern. 8 elements can be considered as one group pattern here. So for references, you can refer the textbooks Antennas and Wave Propagation by E.A. Bakshi, and also K.D. Prasad, that is Antennas Wave Propagation 2001, that is K.D. Prasad. So for these problems, you can refer these two textbooks. So let us close our session today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.